everyone. My name is Samantha Holstein, and I am a developer advocate here at SailPoint. And today we are going to learn all about APIs and how to use them in Identity Security Cloud. So here's what we're covering today. We're going to start off with what REST actually is. It's that foundation everything else builds on. Then we're going to move over to authentication, how you prove who you are. Next is authorization, what you're actually allowed to do once you're in. And then finally, how to read the OpenAPI documentation and actually make your first API call. So let's jump into it. So what actually is a REST API? REST stands for Representational State Transfer, which is a very long name for something that's actually fairly simple. A REST API is a method of transmitting and receiving data over HTTP, following many conventions defined by the HTTP protocol. HTTP is the same protocol that your browser uses every time you load a web page. So, in a sense, you've been using HTTP your entire internet life, and APIs just give you direct access to it. The key word in this definition is conventions. REST isn't a strict standard with rules that you must follow. It's more of an architectural style, a set of patterns that have become so widely adopted that they're effectively universal at this point, which means that once you learn the pattern, it applies almost everywhere. And SailPoint's UI is calling these same APIs. So when you click Request Access in ISC, behind the scenes, it's actually making a post request to the same APIs that we see in the documentation that we can actually call ourselves in Postman. You're not going to learn something separate from the product. You're actually learning the product's own language, which is pretty cool. So let's actually break down what an actual API request is made of. The URLs, the HTTP verbs, headers, query parameters, and JSON. Now, every resource in a REST API has a unique URL that identifies it. So let's build one up piece by piece to see what it looks like. We're going to first start with the host. In this example, it's devrel.api.identitynow.com, and that is the server that we are talking to. This is SailPoint's developer relation team's tenant, but your own tenant URL is going to follow the same pattern here. Next, we're going to add v2026, and this is the base path. This tells the API which version we want. And SailPoint does have other versions of APIs, but as of this recording, 2026 is the most recent and most up-to-date. So we're going to be using that one. Then we're going to add /sources. This is the collection. Think of a collection like a database table. It's the type of thing we're working with. It's sources, it's accounts, identities, roles. Each of those is a collection. And this part of the URL tells the server what kind of thing you're actually looking for. And finally, we're going to add this long alphanumeric ID, and this is called the resource. This is the specific record that we want. It's like a primary key in a database. Without the ID, we're going to ask for the whole collection, all of the roles, all of the entitlements, things like that. But with the ID, we are asking for one specific thing, one role, one entitlement, one part of the collection. So, reading this URL from left to right, we want to go to the SailPoint server. We want version 2026 of our APIs. We want the sources collection, and then we want that specific resource in that collection. The URL is going to tell us the whole story here. And URLs can actually be nested as well to represent relationships between resources. So take a look at this example. It's a little bit different from the URL that we were just looking at. We have a source, that's the parent resource here on the left, /sources. But we can also go deeper. If you see on the right-hand side, starting with that second blue text, /provisioning policies /create, that's saying, give me the create provisioning policy that belongs to this specific source. And the hierarchy in this URL mirrors the hierarchy in your data. So a provisioning policy belongs to the source. In the URL, it lives under the source. So once you see this pattern, you're going to start to recognize it almost everywhere you see a URL. Now, the URL tells the server what resource you want, but it doesn't tell the server what to actually do with this resource. That's the job of an HTTP verb. There are 5 HTTP verbs that tell you what to do with the server with your resource. Let's break them down. We're going to start with get, light blue, on the left-hand side. Get means read. Retrieve one or more resources. There's no extra body, there's no extra pieces of information required to send this here. Everything you need is in the URL. And there were 2 examples in that blue box, get/accounts and get/accounts with a specific ID. Now, actually in the green is post. Post means create. And creating means that you're creating a new resource, or in some cases, it's actually executing an action. For example, in the blue box, post to/accounts creates a new account. And you'll find in the body below that, display name is Allison. That's JSON describing the resource that you want to create. And like I mentioned, post isn't always create. If you are posting to /accounts at a specific ID/enable, for example, this is an action, not a new account that we're creating. The verb is going to tell you the operation, and the URL tells you what to actually operate on. Next on the right-hand side is put, and put means replace. You are sending an entire object back to completely overwrite what exists. Notice the URL includes the ID in it. Put will always target a specific existing resource. Next, in the gray, is patch. And patch means update, but it's a partial update. You only send the fields that you want to change, not the whole object. So that's what the OP is replace syntax in the bottom part of that dark blue box means. And it is a JSON patch operation. Now, a quick note on put versus patch, since these seem fairly similar, and it can get pretty confusing. Put requires the entire object. So if you leave a field out, that field is not going to exist anymore. Patch is a safer option for partial changes. You only touch what you send, not the entire resource. And lastly, in the pink in the middle is delete. Delete means remove, delete. The URL resource gets deleted. So as you can see in the example down here, delete at /accounts/ID removes that specific resource at that ID. Pretty cool, right? We now know how to address a resource and what operation to perform on it. And the last piece is the data itself, and that's where JSON comes in. So let's learn a little bit more about it. JSON, JavaScript Object Notation, is what travels in the body of your requests and responses. Now, despite the name, it has nothing to do with JavaScript specifically. Almost every language in the world can actually parse it. But JSON is what you send in a post or a put request body, and it's also what you get back in your responses. So let's take a look at this identity record here on the left in the pink box. As you can see, it's just key value pairs. Name is Allison. Status is active. Our identity state is active. They are simple strings. Now look about halfway down at manager. That is a nested object. It's basically an object inside of an object. It's pointing to a specific resource that then you can look into further, and those are in curly braces. You'll see this pattern constantly in ISC, and it's just a resource referencing another resource by type of ID, like I mentioned. And then below that, we see attributes. This is an array. It's essentially a list of objects itself, wrapped in square brackets. So again, each item in the list is itself its own object. And now that we have broken down the JSON example, on the right, there are 6 main data types in JSON that may be prevalent when you see anything in the body as well as anything that you might be putting in for your request. And that would be strings, numbers, booleans, objects, nulls, and arrays. Now, there are 2 more things that travel with every request. We're going to move away from the body and now going to head to headers as well as query parameters. So let's start with headers. Headers are metadata. They travel alongside every request like labels on an envelope. The actual content of your request doesn't live in the headers, but more information about what type of request you are actually sending is what this is. The most important header you're going to see is authorization bearer, followed by your access token. And we'll talk about how to get that token here in a moment, but for now, without that authorization header, every API call is going to return an error. We also have content type, and this tells the server what format the request body is in. So if we do application/JSON, it means that the format is going to come back in JSON. Same with accept. It tells you that you want JSON back. And lastly, X total count is a response header that ISC adds to tell you how many total records matched your query, even if pagination means that you only get some of them back. Now, let's move on to query parameters. Query parameters let you filter and sort your results right in the URL. So they come after that question mark, as you can see in that blue box. Multiple parameters are also joined with the ampersand. So the GET request in this blue box means give me an access request status, but only for me, and I want it sorted by the created date. We also have limit and offset, and these are how you paginate. Limit caps the number of records returned. It's mainly maximum of 250 for most ISC endpoints. And offset tells the server where to start. So offset at 0 is going to give you the first record through your limit, and offset at 250 is going to start at the 250th resource, most likely that second page, and so on. Always check the OpenAPI spec to see which query parameters a specific endpoint supports, because not every endpoint is going to support every single filter. And we're going to walk through that documentation here shortly. But now, with that, we have built an entire request. And we're going to send our request now, but what does the server actually give us back? Well, after we make that request, the server is going to send back a response code. That code is your single most important signal about what actually happened with your request. There are 3 families to keep an eye out for. Starting with the 200s in the green, they mean success. Our request worked. This means that we can include a variety of responses from a standard success for our request to maybe you made something new, but that is it and there's no return, or it might give you a return as well with all of the information that you're looking for. Next in the middle is the 400s. This means that we sent something wrong and we need to fix our request. These responses give us a lot of information about the error. Maybe it's the syntax or the data was invalid, the server doesn't know who we are, or we're not authorized to do this request. As you can see, there are a lot of responses, and each one gives us exact instructions on how to fix our request to make sure that it actually works. The 2 errors I do want to point out here are 401 and 403. 401 means that I don't know who you are, and the fix is to get a new token. And 403 means that I know exactly who you are, but you're not allowed to do this. And the fix is to check your scopes in your user level to make sure that everything is correct. And we'll come back to both of those as well. And lastly, on the right-hand side is the 500s. This means that something broke on the server. It's not your fault, and the fix here is just to retry it again later. Now that we know how requests and responses work, let's talk about the part that unlocks everything, and that's how to actually prove who you are. How do we actually do this? Now, authentication in SailPoint follows a 3-step pattern. This pattern never changes, so you can learn it once and use it forever. Step 1 is creating credentials, and our options are a personal access token or OAuth 2 client credentials. These are your long-lived credentials. Think of them like a username and a password for your API integration. And API keys and credentials cannot be used directly in API requests. They're not what goes in that authorization header. They are more of the key you use to get what goes in the authorization header. And we can use these personal access tokens in creating them in the ISC UI. Step 2 is exchanging credentials for a token. We can call post to /OAuth/token with your credentials, and you get back a short-lived access token. Or if we are using the Identity Security Cloud Postman collection, we can actually just enter our credentials and it will post automatically and get that token for you. This token is actually what goes in our authorization header, and it usually expires typically somewhere between 1 and 8 hours. And the reason for adding this second step is for security. If an access token leaks, it's going to expire soon. Our credentials, though, don't expire. We can revoke them if needed, but it's going to limit the blast radius of any sort of security leak with that separate token. And finally, step 3, we get to use the token to call the API. And every single API request will use that authorization bearer with your access token in the header. So that's the whole auth pattern in every call we make. Let's see how this actually works in practice. So I'm going to go to Identity Security Cloud, and we need to create a personal access token. So to do this, I'm going to go to My Profile, Preferences, and Personal Access Token, and I'm going to press New Token. I'm going to give it a name, Dev Days. And I want to point out 2 things here at the bottom before we press create. First is scopes. Scopes give you the option to actually do these specific requests. And we want to give it the least privilege possible. So we're calling the public identities endpoint. So all we need for this is scopes default. The next thing here is the expiration date. We always want to give our personal access tokens an expiration date. It sounds convenient that we do not have to add one, but it is a security risk. A token that never expires is one that can cause damage indefinitely if it ever leaks. So let's click Create. And it gives 2 things here, the client secret and the client ID. We're going to save these here because once we close this window, we're never going to get our secret back. So I'm going to open Postman, and I'm going to set up my environment here. I already have the Postman collection added to my Postman, and this handles the token exchange for us automatically. So I'm going to add my tenant name. This is going to change for what your tenant is going to be. Mine is Devra, and we're going to add our client ID as well as our client secret. And that's it for that. We're already ready to authenticate who we are. So authentication told us who you are. Now authorization tells us what you're allowed to do. Let's draw a clear line between these two. When we're looking at them, the 2 words sound pretty similar. And they are related, but they are completely different things. So let's break down the difference between them. Authentication is verifying that you are who you say you are. So when that server receives your token, it checks, is this token valid? And do I know who issued it? While authorization is what happens next. Once the server knows who you are, it checks, are you allowed to actually do the thing that you're asking? This is exactly why 401 and 403 errors are different. 401 fails at authentication, and 403 passes authentication but fails at authorization. So how does ISC actually decide whether you're allowed to do what you're wanting to do with these calls? In ISC, authorization works through scopes. When you create your personal access token with specific scopes, you can choose which operations that token is allowed to perform, like we did when adding that scope's default to our personal access token. Each scope is its own key that unlocks a specific set of endpoints. So having a create scope does not give you the ability to cancel requests or read any statuses. Those need their own scopes. And this is so granular because this is the principle of least privilege in action. You give the token only the permissions it actually needs for a specific job. And when you're building your integration, the first question you should ask is, what does this integration actually need? And only add the scopes that it needs to do. But scopes aren't the only layer here. ISC has a second authorization check sitting on top, and these are user levels. Some APIs in ISC implement custom authorization on top of scopes. ISC uses both, and both must pass for the request to succeed. If not, we'll get a 403 error. User levels are assigned to the user or service account that your personal access token authenticates as, and they set that broad ceiling for access. You can see the different types of levels in the box on the left, and how this is set up is on the right. I want you to take a look at that box on the right and think of it like this. The outer box is all of the ISC API endpoints. Inside that are only the endpoints that the user level is permitted to use, and then inside that are only the endpoints that the token scopes permit. So your request has to land inside all of these boxes to succeed. So even if a token has the right scope and the user level doesn't permit it, we'll still get that 403 error. Both layers must say yes in order to access. We now know how to build a request and how to authenticate and how authorization works. And the last thing left is to put it all together. And that starts with reading our documentation and making our first call. Now, every SailPoint API endpoint is documented in an OpenAPI specification available at developer.sailpoint.com. So for every endpoint, the spec is going to tell you 8 things: the endpoint URL, the HTTP method, the required scopes, path parameters, query parameters, request body, response schema, and the response codes. So let's take a look at the docs and see these in action. Now, I have opened up the docs here, and we can see the exact endpoint that we are going to call. And this is, if I scroll up, getting a list of public identities. Now, when we look at the top of this documentation page, we have 2 things that always come first. The HTTP verb right here is get, as well as the path right here. Now, at the end, public identities is a collection combined with our specific tenant ID is a URL we're going to be using in Postman. Below that, we have the description, so it gives some information of what we're doing as well as some setup information if necessary. Below that, we have our request, and this has all of our query parameters, all of the options that we can do to filter our request down here. And then finally, at the bottom is our responses. This is what we get back. And as you can see, it has a section for every single response that this will give back, 200s, 400s, and what they actually mean. So in about 60 seconds of reading this page, we now know the full URL to call, what parameters we can pass, and what the responses look like, and what the error codes actually mean. So now let's actually use it. So I'm opening up Postman here, and we already have our environment set up and ready to go. So all I'm going to do here is navigate to the collection, open public identities, and click on Get a List of Public Identities right here. We got to make sure that our environment is correct, and it looks like it is, but we may have to add that in. And all we're going to do is press Send. And just like that, we already got our 200 response code here. That's pretty exciting. Now I want you to notice the structure in the response body here. Each identity is its own object in the curly braces. as well as you can see those key value pairs, just like we were looking at in the JSON before. We also see an array down here, again, a list of those separate objects. But now we're actually able to see it live in that API call. So now let's take a look at the token. This is going to go in the authorization tab right here, as well as you can see all of the variables that get put in here in the variables section on the right. You can see that access token is taken from here, and you see that big long string that we created when we called that post. And we also have a token expiration time, so it tells us how long this token is actually going to be valid for. Now, if we really wanted to add any query parameters like we saw in the docs, we're going to click on the params tab over here. I already have some saved and set up from other API calls, but if you ever want to add more, there's that key and value section here at the bottom. So let's say we only want 5 responses back. We want limit to be 5. As you can see, it already adds that automatically to the URL up here at the top. So when I press send, we're only going to get 5 responses back. Let's check that. 1, 2, 3, 4, and 5. Amazing. Now, we have successfully called the ISC API. We're able to look and see exactly what is happening. And if there's any sort of body, it's going to go in the body tab here, which you can add any sort of form data, you can add GraphQL, raw data, whatever you need to actually put in. So let's recap what we talked about today with a cheat sheet. If you take nothing else away from today, I want you to take this slide right here. Every API call needs 6 things: the URL, so that host, base path, collection, and resource ID, the method, get to read, post to create or act, put or patch to update, and delete to remove, that authorization header with that authorization bearer token always. Without this, nothing works. Our content type is application/JSON. So whenever you're sending a request body, we get JSON back and we send JSON. Our query parameters for filtering and pagination. And always, always check your response code to know what is actually happening with your API call. And that is the entire pattern. It applies to every single endpoint at SailPoint, and you can use that with those API calls. And honestly, every REST API call that you're going to call anywhere. And here are some resources and links for further learning as you continue your journey in ISC and with APIs. Be sure to check out the Collab Marketplace before building anything from scratch, as we have a lot of pre-built connectors, scripts, workflows, and tools that other SailPoint developers have contributed. And also, if you have any questions, if you want to share what you're building, or even browse answers to problems that you haven't even run into yet, check out our developer forum. We also have some pretty fun events on there too, like our monthly live stream, which you're able to go in and learn about a specific topic from experts, whether it's from our developer relations team, someone at SailPoint, or even a community member. Now, I hope that this was helpful in understanding how to break down APIs and how to use them to call the APIs at ISC to take advantage of everything that Identity Security Cloud offers. Thank you so much for your time today.